Hi there, my name's Brian, and I'm one of the hosers here at Gregg Distributors. Today's Heads Up for Hosers is all about getting the right hose for the job, the first time around. If you're setting up a hydraulic system, but you're not sure what type of hose you need, knowing as many parameters as possible ensures that you have the correct hose for your application. To remember the different aspects that make up hose selection, just think stamped. Stamped stands for size, temperature, application, materials, pressure, ends, and delivery. These 7 parameters will help you narrow your focus and find the hose that you need to get the job done. Now, in our first Heads Up for Hosers video, the basics of hydraulics, we already covered this topic. But now we're going to get to see exactly how it relates to helping you choose the best hose for the task at hand. Size refers to the overall dimensions of the hose, including the ID, OD, and length. Hose size is measured using ID, or inside diameter, and steel tubing is measured using OD, or outside diameter. This is particularly important to keep in mind when you are choosing your hose and fittings for your system. The ID of a hose is measured in 1/16 of an inch and is expressed with a dash number. For instance, a -4 hose equals 4 16-inch segments, which is equal to 4/16, or 1/4 inch hose ID. The exception to this rule are hoses designed to replace tube, which are manufactured with an undersized ID to match the ID of the tubing. When assembling a hose, it's important to know when the overall length, or OAL, is critical. For many industrial applications, such as water or general purpose hoses, the OAL isn't critical. But for hydraulic systems, the OAL could be the difference between success and failure. Space restrictions play a big role in hydraulic applications, so be sure to measure your OAL accurately. The OAL of a hose assembly can be determined by measuring from end to end, including the fittings. Remember, male threaded fittings are measured from the end of their threads, female threaded fittings and flange fittings are measured from their sealing surface. And angled fittings are measured from the center of their sealing surface. Keep in mind, as the hose is pressurized, it either expands in diameter and gets shorter, or contracts in diameter and gets longer. This means that there can be a variance, typically between 2 and 4%, in the length of your hose. Make sure to allow enough length so the fittings aren't being tugged or twisted, which could risk damaging the hose or fitting. And avoid stretching the hose, which can restrict fluid flow. If it is scorching hot outside, our skin can burn, dry out, or even blister. And the same goes for hose. Temperature is an important factor when deciding what type of hose to use in an application, particularly where heat is concerned. This applies to both the fluid or material flowing through the hose and the ambient temperature outside of the hose. So you need to know the minimum and maximum temperature for your hose. Extremely high ambient or external temperatures will cause problems such as softening, discoloration, or hardening. This is often visible as thermal stress cracking. The cover may show signs of being dried out and charred, or even crack when flexed. To avoid this, reroute the hose away from the heat source when possible. Ensure that the hose is properly shielded, or choose hose like Matchmate that have a UV inhibitor added to the rubber cover. At extremely low temperatures, hoses will become hard, stiff, and brittle. With further cooling, the material reaches the glass transition temperature. This is a narrow temperature range which causes changes at a molecular level that transitions the hose from a leathery material to a glass-like material. At or below the glass transition temperature, stress, strain, and impact loads will damage and fracture your hose. In operation at very low temperatures, a hose can exhibit fine radial cracks on the surface of the cover and within the inner tube. Hoses in these environments should be routinely inspected and be replaced if they show noticeable damage. And it's not just the temperature outside you have to worry about, but the temperature of the material flowing through the hose as well. Hot fluids beyond the recommended temperature limits may have a similar detrimental effect on the inner tube, reducing the life of your hose. To keep your hose and your system operating safely, be sure to never exceed the maximum operating temperatures. Because if you increase the maximum operating temperature of a hose by 25%, you decrease the life of your hose by half. For hoses that are routinely exposed to high temperatures, ensure that the hose assembly is frequently inspected for any sign of deterioration. A damaged assembly should be immediately replaced with one that has a proper temperature rating. Before selecting a hose, it's important to consider how it will be used, or the application of the assembly. What type of equipment is involved? What are the environmental conditions? Will the assembly be static, or will there be movement such as vibration or flexing? Will the routing be confined? Does the hose need to have the ability to bend in tight situations? These are all questions you should find yourself asking before choosing a hose. Sometimes specific applications need specific hoses. For example, in applications where the hose will encounter abrasive surfaces or come in constant contact with another object, a heavy-duty, abrasion-resistant hose would be best. You'll also want to keep in mind any potential operating temperature swings. That is, changing temperature either in or outside of the hose. In applications where you need to route a hose in tight confines, the bend radius should be considered. The bend radius is the minimum radius you can bend a hose without kinking it, damaging it, or otherwise shortening its life. The bend radius is measured as the distance to the inside edge of the hose when making a 90-degree bend. When a hose is pushed past its bend radius, it can restrict the flow and damage the hose or shorten its performance life. For example, a smaller bend radius means better performance in situations that require tight routing. Always be sure to know how much a hose is going to need to bend under pressure, so you know that you're getting the right hose for your application. Hoses are built and tested according to industry-specified standards. These standards vary based on location. The SAE, or Society of Automotive Engineers, classification is the North American standard, while the CEN, or European Committee for Standardization, classification is the European standard. ISO, or the International Organization for Standardization, is a global unit that is better known for its process standards. For instance, here at Gregg's, we are ISO 9001 certified. There are also ISO product standards, which are becoming more prevalent in the hose industry. These standards, ISO, SAE, and CEN, are minimum benchmarks to assure quality in the marketplace. However, be careful. These standards aren't mandatory, and just because similar products may meet the same standard, that doesn't mean they're compatible with one another. Never use fittings from one manufacturer with hose from another. You'll run the risk of a system failure. M stands for material, which is the solid, fluid, or gas that is being transported through a hose. For solids, you need to know their size and type. For gaseous applications, it's important to know if they are inert, as in they won't affect the hose, or volatile, as in they might react with the material in the hose or the surrounding atmosphere. Any rubber-covered hose used for gaseous applications requires pin pricking, which allows gas to escape and prevents blistering in the cover. Some applications require the use of specialized oils or chemicals, and it's critical that the hose you choose for the job is compatible with the material it's transporting. Compatibility includes the inner tube, the cover, the hose fittings, and the O-rings as well. If your material isn't compatible with the hose, it will result in shortened lifespan of the hose and ultimately hose failure. This chart provides a good reference for your compatibility. You'll notice that each type of tubing has different levels of compatibility. Always follow the manufacturer's guidelines, but remember, material compatibility is only one step of the selection process. Next up is pressure, which is the force exerted on the inside walls of a hose. This is measured in PSI, pounds per square inch, or bar. PSI is the standard unit of measurement in North America, while bar, which is not approved as part of the International System of Units, is used more commonly in Europe or with international engineering. Hose pressure is measured by three standards: maximum operating pressure, proof pressure, and minimum burst pressure. Maximum operating pressure is the maximum pressure a hose is designed to handle on a continual basis, including any pressure surges or spikes. Proof pressure is the testing pressure, which is 2 times the maximum operating pressure. And minimum burst pressure is the minimum amount of pressure a hose must be able to withstand before failing. The industry standard is that the burst pressure level should be 4 times the maximum operating pressure, without any pressure surges or spikes. The maximum operating pressure will be listed right on your hose lay line. Too much pressure and your hose could burst. Too little and you risk creating a vacuum. A vacuum is the state of negative pressure. In a hydraulic system, this usually means hose collapse, which is exactly what we want to avoid. A vacuum is created on the suction side of a pump, or the side where the fluid is drawn in. Hoses used on this side of the pump need to have a vacuum rating, which is rated in either Hg, inches of mercury on a scale of 0 to 30, or kilopascals. Hoses that are designed to handle a vacuum usually have a wire helix to prevent the hose from collapsing. Without calculating the pressure in your system, you could have hoses collapse, leading to the disruption of flow or even a hose burst at the other end of the line. You can find the pressure of your system either by using a pressure gauge, contacting the manufacturer of the system, or by giving your local Greggs a call. Our hose specialist would be more than happy to help you. The right hose with the right end connection keeps your system operating safely and effectively. Ends refers to the fittings or connections at the end of your hose. Your choice of end will rely heavily on the application of the hose assembly, but it's also critical to determine the style, type, orientation, system pressure, and attachment method of your ends. End connections are where the most leaks in a system occur, so selecting the correct end and using the correct attachment method will reduce potential leaks and eliminate the risk and danger that comes from an improperly installed fitting. There are 2 main types of ends: crimped and reusable. Crimped ends are specific to the style of hose and are a permanent attachment created using mechanical force. These ends require a crimping machine to attach the fitting to the hose and come in either 1 or 2 pieces. A reusable end consists of 2 pieces, a socket and a stem, which are designed for their specific application and aren't interchangeable. In some high heat or extreme pressure hydraulic applications, some of the hose cover is removed. This process of removing the cover far enough from the cut edge to allow your socket or crimp sleeve to grip the wire reinforcement is called skiving. This allows for a leak-proof seal and prevents fitting blow-off. Note that this only applies to hoses with wire reinforcement layers. On the other hand, a non-skive is a type of fitting which allows a socket or crimp sleeve to be installed over top the hose cover, gripping the wire reinforcement via teeth penetrating through the cover to create a seal. This is also referred to as a TTC, or through the cover seal. But sealing isn't all you have to worry about in a hydraulic assembly. Orientation plays a major role as well. This is crucial if 2 angled fittings are used in an assembly. That's because every 7 degrees of twist in a hose reduces the life of that hose by as much as 90%. To prolong the life of a hose, you need to know how it's going to be routed. Will it be straight, or on a 45 or 90 degree angle? Does the end need to stay in place, or does it need to swivel? These are all questions you'll need to ask yourself before choosing the best ends for the job. The final step in choosing a hose is delivery. When is it needed, and how many assemblies are required? Do you need 10 feet of 8-inch industrial hose tomorrow? Or 50 feet of brake line 3 weeks from now? Depending on what type of hose and how much is required, you'll have a different delivery window. So remember, if you get lost while trying to choose the best hose for the job, think stamped. And if you're still unsure, feel free to give us a call or drop by our website at greggdistributors.ca. Our friendly staff would be more than welcome to show you some good old Canadian hospitality. Again, I'm Brian, and thanks for joining me on another great round of Heads Up for Hosers.